Good evening, how are we all doing? Way. That was a bit of a muted response, but it shows me that you're all using your brains, which is great. Some of you might argue that some people maybe use their brains less than others. Now, this evening I want to tell you more about the brain because I'm a neuroscientist. I want to tell you about the cells within the brain, how they function, and sometimes how they might go wrong in disease. So, brain cells. I want to introduce you to Nellie. Nellie is a neuron or a brain cell. And the important thing about brain cells is that they can send messages to one another. But unlike the texts, emails, or WhatsApp messages that we might use, neurons have a very particular way of sending messages. They do this in two ways. The first way is electricity. Nellie's lighting up here. She's using electricity to pass a message from one end to the other. Brain cells can do that, but the problem comes when the next brain cell, there's probably a gap between them, a physical gap in space. And brain cells get over this problem by using something called neurotransmission. They use neurotransmitters or chemicals to cross that gap. Now this evening, I'm going to represent neurotransmission with bubbles. And this is actually really accurate. Neurotransmitters, chemicals, cross the synaptic cleft, that gap, that space, in bubble form. Now, unfortunately, in a disease like Parkinson's disease, a neurodegenerative disease that affects the brain, we know that these cells no longer produce dopamine. That's a neurotransmitter that is involved in Parkinson's disease. And because there is no dopamine, unfortunately, the brain cell will no longer be able to communicate. It will turn off. And unfortunately, we know that the brain cell will die. Now, this is a problem for Parkinson's disease and a range of other neurodegenerative diseases. So what we're doing is trying to transplant healthy cells that have the capability to transmit those messages and also produce dopamine. If we can transplant these healthy cells back into the brain, then we might have a hope of helping patients who are living with this condition. And that is how we're looking to repair broken brains. Thank you.